Good morning, Year 7. How lovely to see you back after Easter. Hopefully we're all getting quite good with these videos now. You are going to need pen, you are going to need pencil. You will need to pause the video at certain times and hopefully we'll all have some fun. Now you've got your title for today on here, Carbon Cycle and Global Warming. You've also got a do now, quite a quick and easy one. You need to make a food chain using these organisms, grass, rabbit and fox. You have to label consumers and producers. I would suggest that you pause the video while you do this. The answer is on the next slide, so don't worry about knowing it all. And here is the answer. Remember, grass goes first, then rabbit, then fox. I've labelled the producer and the consumers. We've got primary and secondary consumers. Check the direction your arrow goes. Remember, the arrows show energy transfer. They don't show which organisms eat which other ones, because the grass does not eat the rabbit unless something's gone very strange in your garden. Sure, we all got that right. So let's have a look at today's objectives now. After this week's lesson, we're going to know what the carbon cycle is, how it works, how humans can affect the carbon cycle, either in a positive or a negative way, understand how global warming occurs, and think about how to counteract global warming. And if you look out during this presentation, you will probably find some learning from some of our other topics this term, and also some learning that you have done in geography. Now, pens and papers at the ready to make some notes. You don't need to write the objectives down unless you want to. We will have a review at the end as usual. So first of all, carbon. Little screenshot here to show you the information from your periodic table, just in case you haven't got it to hand with you. It's a sixth element. It has got 6 protons. We know that because the small number at the top is a 6. That's the number of protons. The number at the bottom is 12, which is protons plus neutrons. So we can work out there have got to be 6 neutrons, because 6 add 6 makes 12. And there are also 6 electrons, because the number of protons and electrons have to match in order for it to be an element without a charge. Carbon is a non-metal. It doesn't conduct heat or electricity, and it is a solid at room temperature. You probably want to write these points down just so you remember key information to make it easier for you later on. Now we're going to be thinking about cycles today. Little diagram to show that a cycle is like a circle. Elements go from one to the other, and it doesn't matter where you begin, because you will always go in a circle, so you'll always end up back at the start. There's a law you might have heard of, which is the law of conservation of matter. And this says that everything in the universe is already made. There's a certain amount of carbon, hydrogen, oxygen, everything in the universe, every single element on the periodic table. You can't make them. You can't destroy them, but what can happen is that the forms that they are in can change. So you could get it as a pure element, you could get it as a compound. And that is what the cycle will tell us, how the different carbon changes from one form to another. So, where is carbon found? As an element, it can be found as coal, we'll know that one, diamonds, and graphene, which is actually the middle bit of a pencil. The bit you call a lead isn't actually lead, it's actually carbon. It can be found in compounds. We all know about carbon dioxide, CO2, and we all know about glucose, also known as sugar, C6H12O6. That's one of the more complicated compounds we tried to learn the formula for this year. It can also be found in rocks and shells as a compound again, calcium carbonate, sometimes called chalk. And those are just a few examples. I'm sure you know lots more. You'll want to write these down, because it's easier than trying to just remember them all. Remember to pause it while you write them down. Now, there's going to be a video to watch on the slide after this. It lasts 4 minutes, and you've got 4 questions to answer. So write the questions down in your book. Leave a couple of lines underneath each one, so you've got a space to write the answer. So we need to be looking out for how carbon is stored on the earth, What is a carbon sink? It's not the same as your kitchen sink. How do people disrupt the carbon cycle? And how can we help to rebalance the cycle? This is really important. Now, video link is shown here. It's a YouTube video, of course. If you can't get the link to work from this video, then all you need to do is copy and paste it into your browser. After pausing the video, you can watch it. You probably need to watch it twice, once to get a feel for what's in there, and the second time to make sure you've got the answers. Remember, you can pause that video as you go as well to write down. You don't have to do speed writing. And global warming is a hot topic. You'll find lots in the news about this. It's actually very current at the moment because global warming is being affected by coronavirus. I'm not telling you which way. You try and find out, or bonus R points. Here are the answers to the questions. Remember, I wrote sentence questions, so I've expected you to write sentence answers. They don't have to be word for word, the same as mine, but it actually gives you an idea of what should be included. And oh, look at that, number 3, there's a link to last week's learning. Told you there would be links. Now, going back to a cycle, here I've got a similar diagram from before. I put carbon dioxide in the atmosphere in one of the text boxes. And you can draw just words, you can do pictures, whatever you'd like. Have a go to see what you can do for drawing a cycle using the information from the video. Remember, if you need to go back to the video, you can. The next slide does actually have an example with pictures and words to just let you have a look, see how close you were. It doesn't matter if you're right or wrong. We're having a go at organising information. It's another way of doing it. We've already used notes, we've used mind maps, we've used knowledge organisers. Now we're looking at cycles. And here is an example of the carbon cycle. So carbon dioxide is exchanged between the air and the sea. So if the sea has lots of carbon dioxide, it'll let it out into the atmosphere. At the moment, the atmosphere has a lot more carbon dioxide than the sea. The danger is when carbon dioxide goes into the sea, it can actually make the sea more acidic. This isn't good because that will actually have an impact on the organisms living in the sea. If it becomes too acidic, one of the predictions is that the only organisms left there will be jellyfish. And I don't know about you, but jellyfish and chips on a Friday night doesn't sound quite as good as cod and chips. Now, carbon dioxide in the atmosphere can be removed by the sea. It can also be removed by plants. Plants need carbon dioxide when they perform photosynthesis. And when they use the light energy from the sun, carbon dioxide from the atmosphere, they trap carbon inside them in the form of glucose, starch. You see it in potatoes, we eat that starch. It also is the main material for wood in trees. So if you've got a big tree that's growing, that tree is capturing carbon dioxide out of the atmosphere the whole time. It won't be released until the tree either dies and decays, which is a slow release, or it's chopped down and burnt, which is not such a slow release. Animals can also eat the plants. At that point, they will take the carbon dioxide into them, and two things can happen. They can either breathe it out, like we do, they can grow, increase their own bulk, or they can actually pass carbon out as other gases, such as methane. You might have seen in the news, there's lots of talk about cows for burgers producing lots of methane and being a cause of global warming. Humans will also burn fossil fuels such as gas and coal in factories and power plants, and that will release carbon dioxide into the atmosphere. The fossil fuels are so called because they are made from dead things that have been fossilised. Amazing name, hey? Wouldn't have guessed that. So you will have bits of fossil in there, you'll have bits of bone or bits of leaves that are still recognisable, but most of the organic material has changed form over millions of years and being compressed. And you can also have organic material trapped in stones such as limestone, which is made basically from crushed shells and bones from sea creatures. So you've got quite a nice cycle here. It's first cycle we know about. There are other cycles for other elements as well, which we will learn about later on. Now, as a big finish, we have got a song. It is a rap song, another YouTube clip. You might like it. You might think you could do better. If you could do better, please have a go at writing a song, a rap or poem. If you want to video yourself performing it and send it in to me, that'd be great. Who knows, you could be on Britain's Got Talent, or maybe Sam Ward's Got Talent. Now, can you be the change that will actually be a change for good? If it's not going to be you, then who is it going to be? Spoiler alert here, next week's lesson will be all about plastics. So I'm going to need you to collect 5 different types of plastic waste this week to be ready for next week. If they've had food on them, please make sure they're washed and clean. Tell an adult you live with what you are doing, why you are collecting them, so that when you've got a nice little pile on the side, somebody doesn't throw them out the day before and end up with a disagreement. Okay, then next week's activity will be like a little mini practical you can do at home, because I'd hate you not to do any practicals while you're not at school. Now, last thing we always do is we come along to our review of the objectives. You have to know how the carbon cycle works, explore the impact of humans on the carbon cycle. Where was it that we had an effect? What could we do to counteract them? Think about how carbon cycle fits in with global warming. What links have you found between this lesson and our earlier learning? How does this fit in with waste treatment, composting, deforestation? Can you see that all these topics are not individual? Everything is linked. Everything we do has an effect on every other thing. Now, I would like to see some of your work from this. I have had some great work sent in by Year 7s already. I've had lovely pictures sent in, and I have awarded quite a lot of R points. There will be R points for every piece of work that is submitted. There will be R points also for people that complete your Seneca assignment. More information about that on your class email. Looking forward to hearing from you soon. Keep safe, keep well, keep learning. Bye for now, Year 7.